Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty, and today we will discuss about the gas turbine cycle with intercooling and reheating. So all of us know that both intercooling and reheating helps us in improving the specific work output of a gas turbine cycle. Now we'll discuss in details how the components like intercooler and reheater helps in improving the specific work output when both are integral part of the gas turbine system. So let me first draw the schematic diagram. So you do have first the first stage compression, then this is taken to an intercooler, and then it is taken to the second stage of compression, which is also known as your high pressure compression. After that, it is taken to the combustion chamber, where both heat and fuel are added. Then it is taken to the first stage of the turbine. After that, it is taken to the reheater. Then it is taken to the second stage of the turbine, and finally it is exhausted. So air in, this is your exhaust, this is LP compression, low pressure compression. This one is your intercooler. This is your HP compression. This one is the combustion chamber. Heat and fuel are added. Then this one is the first stage turbine. This one is your second stage turbine. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is your reheater, and then this one is 8. So let me first explain how the system actually works. First, air is taken into the LP compression or low pressure compression, where it is compressed to an intermediate pressure. After that, it is taken to the intercooler, where it is cooled, and after being cooled, the air is brought to the HP compressor or high pressure compressor, and then it is taken to the combustion chamber, where heat and fuel is added, and after that the high pressure, high temperature gas enters the first stage of the turbine, where it undergoes expansion, and after that it is taken to the reheater, where further heat is added, and then it is taken to the second stage of the turbine, and you get power output, and the exhaust gases is delivered to the surrounding. This is the way actually the gas turbine cycle with intercooling and reheating works. Now, let me draw the PV and TS diagram to explain the different processes. Your process 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, and 7, 8. The same thing is shown in the temperature entropy diagram. Now let me explain the different processes and we'll analyze how there is increase in specific work output by providing such arrangements. First, it is compressed in the LP compression. This is also known as your first stage compression. So don't get confused if somebody says the first stage compression. Then it is taken to the intercooler where it is cold. And then it is taken to the HP compression. 3, 4 represents the compression that is taking place in the HP compression or second stage compression. And then heat addition takes place in process 4, 5, that is in the combustion chamber. After that, it is taken to the first stage of the turbine where it expands and does some mechanical work. The first stage turbine is also known as your compressor turbine. We call it compressor turbine because it meets the requirement of both the compressors. The work input that is to be given to the compressors, both LP compressor and HP compressors, are obtained from the first stage turbine. And after that, it enters the reheater where further heat is added, and after that, it actually goes to the second stage turbine where it expands. The second stage turbine is also known as power turbine because this is the net work output that we obtain, or the net power that is obtained. Because this turbine, first stage turbine, meets the requirement of the compression, this actually develops the power which is utilized. Now, this is the gain in work output on account of providing the intercooler, and this is the net work output gained by providing the reheater. While discussing the intercooling, reheating and regeneration, I have told you that when you do have individual components, how they contribute towards specific work output, or how specific work output is increased. Let me again tell you how this is happening. Process 2-3 is a process that is taking place at constant pressure, and all of us know that as for combined gas equation, PV by T is equal to constant. When that is taking place at constant pressure, this becomes V by T is equal to constant. So when you provide an intercooler, you cool it, you reduce the temperature. As you reduce the temperature, to keep the ratio same, this volume will automatically get reduced. The same thing is happening here. So due to this, you get more work output by reducing the compression work. The same thing is happening when it comes to your reheating, but in a different way. In this case also, we are gaining some work output, how this is happening, because here heat is being added. Again, you know that combined gas equation is given by PV by T is equal to constant. This heat addition process is taking place at constant pressure. So this reduces to V by T is equal to constant. So as you are adding heat means you are raising its temperature, the volume will automatically get raised. So it is reaching V7 from V6. So this is the gain in work output that we get by providing the reheater. So there is net gain in work output by providing the intercooler as well as reheater. But as far as the efficiency is concerned, the efficiency is not increased by providing the intercooler and reheater. All of us know that efficiency is equal to W net divided by heat supplied. In a cyclic process, W net is equal to Q net. That is the net heat supplied minus heat rejected is Q net by Qs. And here, as far as the work output is concerned, you can say that W net, you may represent this as WT1 plus WT2 that you are getting in both first and second stages of the turbine minus the work that is being consumed in LP compressor or first stage compressor or HP compressor or second stage compressor, that is WC1 plus WC2 divided by the heat supplied, and heat supplied is also taking place in two stages. You can say that this is the heat supplied. Okay, you can say QS1 plus QS2. This is the heat supplied. This is, you can say, QS1, and this is your QS2. And similarly, you can put the values in terms of heat supplied and heat rejected. But in both the cases, what is being observed, that more amount of heat is being supplied, because had it been a single process without intercooling and reheating, the heat supplied by considering unit mass would have been the difference in enthalpy between this point and this point. But now heat addition is actually taking place first from 4 to 5, then from 6 to 7. So although there is gain in specific work output, the efficiency is not improved, it is decreased. But still it is useful because it helps in improving the specific work output of the cycle. This lecture would be extremely useful in understanding the concept of gas turbine cycle with intercooling and reheating. I will take separate lectures to discuss the combination of intercooling and regeneration and reheating and regeneration, and also when you are having a gas turbine cycle with intercooling, reheating and regeneration. If you have any doubt related to this lecture, please do put questions so that I will try to answer. Don't forget to subscribe to my channel if you have not done so till now. I would request you to share this with your friends and relatives. Thank you very much for watching this video. Hope to see you soon for another lecture on my YouTube channel, Erudispace.